everyone, the topic we're going to introduce is quantum entanglement spooky action at a distance. First, we want to talk about quantum superposition.
好，来，我猜，我骰是7，对不对？
最好为什么？你怎么可能猜？
来，咱们来看，不可能，
怎么可能
Wow, how did you know that? The state of the dice hadn't been determined.
Well, I just take a guess, and I think that the state of the dice should be determined before I take the guess.
No. Have you ever heard about quantum mechanics? In the perspective of quantum mechanics, the state of the dice should be determined when we solve it.
But how can the state of the dice change after we stop shaking it?
Oh, just like you said. You just guessed it, so how can we call it determined?
Well, that makes sense. So before we observe the dice, we can only describe the state of the dice with probability. This is what is called quantum superposition. Means when the quantum system hasn't been measured or observed, it can be multiple different states at the same time. Next, we're going to introduce the concept of quantum entanglement. Let's say there's a stationary ball with a zero spin. Now it's split into two balls and both rotating. According to quantum mechanics, the rotation direction won't be determined until we observed it. Once we observe A, we know it's rotating clockwise or counterclockwise. We can know ball B must be rotating in opposite direction. That makes the total angular momentum of the two balls zero. Quantum entanglement means two or more particles exist in entangled state, and even if they're far apart, a change in the state of one particle will instantaneously affect the other particle. Let's move on to some interesting stories about some scientists who have different opinions about quantum entanglement. One day in 1935, when Einstein was spending his time on Facebook, he accidentally saw the post that the three scientists of Copenhagen have posted in 1927. But from the Copenhagen interpretation, Einstein's special relativity will be violated, because nothing can travel faster than light. He called on the two of his fellow scientists, Boris Podolsky and Nathan Rosen, and sometimes later they published the hidden variable theory. They think there are some unknown factors that make the quantum unpredictable.
In 1964, Bell saw a new article about Einstein's disagreement with Copenhagen interpretation. Soon, Bell proposed Bell's theorem. If hidden variable theory is right, they will follow Bell's inequality. But if the Copenhagen interpretation is correct, then this will break Bell's inequality. 5 years later, in 1969, another scientist named John Clauser made the first Bell test. The result shows there were no unknown factors, but this experiment design was questioned. To make up for the loophole of Clauser's experiment, Aspect made a second Bell's experiment, and the result violated Bell's inequality again. After that, many scientists constantly improved the experiment, and the results still break Bell's inequality again and again. Building on the achievements of previous experiments, Anton Zeilinger was the first to realize quantum interpretation of independent qubits, expanded its work into quantum information transfer, establishing the fundamental concept of quantum communication.